Hey guys, this is 10-4. We're going to be talking about the area of regular polygons, and there's two words in there I want you to understand. First is polygon. So polygon is a shape with more than two sides, and they all connect. All the sides are straight and they connect. All right. The second word that you might not have heard of before is regular. Regular means all the sides are the same size. So a regular rectangle would be a square. Okay? A regular triangle would be an equilateral triangle. So we are going to be finding the areas of a bunch of different polygons, but they are all regular, and that's important. They all have the same size sides. Ooh, tongue twister. Okay, so let's get some definitions here. So the distance from the center of a polygon to any side, so it has to be perpendicular as well. So from the center of the polygon to any side. So let's choose this side, and the distance must be perpendicular to that side. That is called, and this is a difficult word, apothem. I'm going to be using that word often, so make sure you remember that one and study it a little bit. All right, the next one. The blank of a regular polygon is the distance from the center to a vertex. Center to a vertex. That is called, as you know, the radius. Similar to what we call the distance from the center to any point on a circle. This is going to be from the center to a vertex. A vertex are these points. So in a triangle, there's three. This is a 1, 2, 3, 4, 5, 6 hexagon, so there's 6. So we call that the radius. Now, to be able to find the area of a regular polygon, we find half of the apothem times the perimeter, which is pretty cool. So what we're basically doing is we're finding the area of all these triangles and we're adding them together. So to find the area of the triangle, we need the height, and we need the base. So we do that and then we multiply it by how many bases we have, or how many triangles we have, and that is going to be what the perimeter is. So it ends up working out where we just multiply, we find one triangle, we multiply by how many triangles we have. That's basically what the formula is doing. Okay, so for this triangle, number 1, we have the apothem. This is a regular polygon, meaning all sides are the same. So this is 24.2, this is 24.2. Now normally we would just do the height times the base, but we don't have the height. So this is a trick. We have the area to be 1/2. Do we have the apothem? We do, 7 times the perimeter. Okay, so now we have to go back. What is the perimeter of a triangle? It's just the distance around. So we're going to have 24.2 plus 24.2 plus 24.2, which is the same thing as multiplying by 3. So that is going to give us 72.6. And then when we combine all that, we get our area. So that is another clever way to be able to find the area of a triangle. We have area equals half base times height. Now we have area equals the apothem times 1/2 times the perimeter. Cool. Same with number 2. Number 2, if it gives us the side, 13.3, it's a regular polygon, which means this is 13.3, this is 13.3, so on, so on, so on. And how many sides are there? 1, 2, 3, 4, 5, 6, 7, 8. So it's an octagon. So our area is going to be 1/2 times the apothem, the distance from the center perpendicular to one of the sides. So that's 16 times the perimeter. We don't know the perimeter yet. Perimeter is going to equal one of the sides times how many sides there are, 8. So that is going to give us 106.4. And so we get 850, not 4, 851.2 centimeters squared. That is the area of this octagon. Pretty cool. All right, so now there are steps to be able to find the apothem and the side length if one of them isn't given. This is where it gets a little bit tricky. And this is where we're going to need our trig. And using our trig, 45, 45, 90 triangles and our 30, 60, 90 triangles, that's one way. Another thing we need to know is the measure of the interior angles of, say, a shape that's more than 4 sides. We know a 3-side shape has 180 degrees. We know a 4-side shape, all the interior angles add to 360. What about if we go to a 5-sided shape? So let's get a rule here real quick. So we have a 3-sided shape, we know is a triangle, has 180 degrees. 4-sided, 360. I'm not going to draw them. 5-sided. Now what? What do you think? Do you see a pattern? Yeah, we add another 180. About 6 sides, another 180. So on. So this is going to be n for how many sides? Sides. How do we get a definition for this? Including n. So what we do is it's going to be something times 180. So when we have 3 sides, how do we get this to multiply by 180 to give us 3 sides? So that's going to be n minus 1. If we had 3 sides, so if n equals 3, that would give us, n minus 2, not n minus 3, n minus 2. So that would give us 1 times 180, and that gives us 180 degrees. What if n was 4? That would give us 4 minus 2 times 180, which gives us 2 times 180, which is 360, and so on. If n equals 5, that gives us 5 minus 2 times 180, which equals 540. So that is our rule. So it's going to be n minus 2 times 180, where n is the number of sides. That's how you know how many, so what the sum of the interior angles is in that polygon. So let's go back. Okay, and remember it's a regular polygon. In a regular polygon, all the angles are the same. So a regular polygon, all the angles are the same. So in a triangle, they would all be 60 degrees, 60 degrees, 60 degrees. So it gives us the apothem. Now we need to find what is this? If we can find that, we can find the area. So this is going to be a little bit tricky. Since this whole thing is 60, we know that every angle is 60 degrees. That must mean this is 30, because it's half of it. And this is going to be 60. Let me change my point so it's smaller here. Oops. Okay, so if this whole thing is 60, that must mean if we go to the vertex, and this is a equilateral triangle, that must mean this is 30 and this is 60. So if we have one side is 18, that's the 30 side. Remember with a 30, 60, 90, we have x, 2x, x squared roots of 3. So if the 30 we have, that's 18. We need the 60. So the 60 is going to be, what is it? Yeah, 18 square roots of 3, good. And then the hypotenuse is going to be 36, but we don't need that, we don't care. We are looking for this. So now we have half of one of the sides. And since this is also then going to be 18 square roots of 3, we can find what the actual side is. There we go. So the side is going to be approximately 18 square roots of 3 plus 18 square roots of 3 is going to be approximately 62.36. Okay. So there we go, 62.36 for the side. So now we have that. We can find the area here, because each side is then going to be 62.36. So the area is going to be 1/2 times the apothem times the perimeter. So the perimeter is going to be 62.36 times how many sides there are, which is just going to be, what, 187.08? 187.08. And so when we do all that, we get 1,683.72 millimeters squared. Okay, so you got to remember your 45, 45, 90s and your 30, 60, 90 triangles to be able to help us in this. So for number 6, we have to first figure out how many sides there are so we can figure out how many degrees the internal angles add up to. So let's do it. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 sides. So our formula is where n equals 8. So it's going to be 6 times 180. So the amount of degrees in this triangle is going to be 6 times 180. Oh man, can you do that in your head? So you do 18 times 6 and then add a 0. So that's 1,080 degrees. So this is going to have 1,080 degrees for the internal angles. Okay, and then you can see how many angles are there? 1, 2, 3, 4, 5, 6, 7, 8. The same amount, and they're all equal. So it would be x plus x all the way to 8. So 8 times x. 8 times x equals 1080. So x is going to equal 135 degrees. So each angle is 135 degrees. That's good to know. So this is going to be 135 degrees, as every angle will be. So what we need to do is we need to find the area of one of these triangles. And to do that, let's go in a little bit. So we know this whole angle is 135. So what we are going to do is take half of that. So half of 135 is 67.5. Oh man, that doesn't help us. We're looking for this guy, because that's going to be the same as this. And if we can find that, we're good to go. So how do we find that? It's not a 30, 45, 30, 60, 90, or 45, 45. This is 67.5. So what do we have to do to find this? Yeah, we could use SOHCAHTOA. Because we have a 90-degree triangle, we are looking for the adjacent side, and we're given this to be 6 kilometers, which is the opposite side. So the tangent is what we'll use. Tangent of 67.5 is going to equal opposite over adjacent. So to solve for x, we get x equals 6 over. Make sure your calculator is in degree mode. And we get x to be approximately 2.49. So we found our x. So our x is going to be 2.49, which means this is going to be 2.49. So our full side is going to be what? 2.49 plus 2.49, which is 4.98. So each side is 4.98, 4.98, 4.98. Pretty cool. So we have our apothem, they gave us that. So the area is going to be 1/2 times our apothem times the perimeter. So the perimeter is going to be 4.98 times how many sides there are? Just 39.84. So that is going to give us 119.52 kilometers squared. Nice. Cool. Good problems. Number 8. So they give us the side, and we're trying to find the apothem now. So first thing, how many sides? 1, 2, 3, 4, 5, 6. So 6 sides. N equals 6. So 6 minus 2 times 180 will give us 4 times 180, which is 360. So 720 degrees for the internal angles. And there's 6 sides. So x plus x plus x plus x. Sorry, 6 angles. 3, 4, 5. So since there's 6 angles, we could do it this way. And then we could do the shorter way. So 6x equals 720. X equals what? For each angle, for number 8, we do 720 divided by 6, which will give us 120 degrees. So each angle is 120 degrees. Good to know. So 120 plus 120 plus 120 plus 120 plus 120 plus 120 gives us 720. All right, so we are looking for the apothem here. So let's zoom in a little bit. We know this has got to be 90 degrees, which means this and this got to be 11 and 11. So we do our radius. And we know this whole angle is 120. So half of 120 is 60. Oh, good. It's a 30, 60, 91. So our 30 is 11, which means our 90 is going to be 22. And our 60 would be 11 square roots of 3. So what's the one we're looking for here? We're looking for the 60. We're looking for the height. 11 square roots of 3. So our apothem is 11 square roots of 3. Side is 22. And there we go. We can solve this. So our perimeter, if each side is 22, and there's 6 sides, that means there is 132 distance around, and it's in what yards? 132 yards. So our area is going to be 1/2 times the apothem times the perimeter. There we go. And that's going to give you approximately this, not 03. Okay, there we go. Number 9, same idea. We're just going to have to turn it a little bit here. So I'm going to erase this. They give us the side. There's 3 sides, so we know the angles add up to 180 degrees, which means each angle is 60. 60, because they are all regular polygons. And regular means all sides are the same, which means all the angles are the same. So this is also 9, this is also 9. So what we're going to do is we need to find the apothem here. We could do the area of a equilateral triangle formula, if you knew that, or we could do law of cosines, but this is another way of doing it. We could then, let's zoom in here, draw our radius. Since we are splitting in half, we know each of these sides is going to be 4.5, 4.5, and we're looking for this guy. So since these are 60, that means this must be 30, and this must be 60. Oh boy. So we could always do SOHCAHTOA. That's always a possibility. Since this is 4.5, that might not be a bad idea, to be honest. So let's do it anyway. So we know 30, 60, 90. This is going to be x. This is going to be x squared roots of 3. This is going to be 2x. Now we have our 60, and this is 4.5. We need to find x. So we know x squared roots of 3 equals 4.5. So we solve for x. X is going to be 4.5 divided by square root of 3. Since we're just looking for a decimal, that's fine. We could find that. So that is going to be approximately 2.6. There we go. That's not too bad. So our apothem we can find. Our apothem is going to be 2.6. Cool. So we have our apothem, we have our sides. So here we go. So our area is going to equal 1/2 times our apothem, 2.6. And remember, each side is 9. So our perimeter is going to be 9 plus 9 plus 9, which is 27. So that is going to give us 35.1 centimeters squared. Cool. All right, so for number 12, we first need to figure out how many sides we have. So 1, 2, 3, 4, 5, 6. So n equals 6. And our formula is this. So we're going to get 6 minus 2 over 180, which is going to give us 720 degrees. So 720 degrees, we divide that by how many angles there are. So there's x plus x plus x plus x plus x plus x. So x is going to give us 120 degrees after we solve for that. So for this one, they're giving us the radius. We need to find the apothem and we need to find the side length. So here we go. We have our apothem right here. So we need this and we need our side length. Can we do that? Let's see. So we know this angle is 120, so half of it would be 60. Yep. So we have a 30, 60, 90 triangle. We have one of the sides. We can find the rest. Very cool. So we have 30, 60, 90. That's x. Oops. X squared roots of 3, 2x. So they give us the 90. So the 90 is 12.5. So we can easily find the x because 2x equals 12.5. So x equals 6.25. So in this case, that is our side opposite the 30-degree angle, which is y. So our y is going to be 6.25. So now, not degrees, whoops. So now that we have 6.25, we could find our x by doing the Pythagorean theorem, or we know the 60 side is, oops, times this 6.25. Oops, let's give us some more room. The x squared root of 3 equals 6.25, that's our x, times square root of 3. So what is that? What's 6.25 times the square root of 3? That is approximately 10.83. So there's our apothem. So, oops. So there we go, 10.83. Our half over one side, 6.25. The other half is 6.25. So the full side is 12.5. Good to know. So when we're looking for the perimeter, we have 12.5 times how many sides there are. There's 6 sides. So that's going to give us 75. So there's our perimeter. So our area is going to be 1/2 times the apothem, which is 12.83, or 10.83, times the perimeter, 75. That's going to give us approximately 406.13, and then the units are feet. So feet squared. Cool. Number 14. Again, they give us the radius. Let's do it down here to not confuse us. So this is 19. How many sides are there? 1, 2, 3, 4, 5. So n equals 5. 5 minus 2 times 180. That's going to give us 540 degrees. So each angle is 540 divided by 5. So we have 5x equals 540. X equals 108. Okay, so this angle is going to be 108 degrees, which means when we do our apothem, that's what we're looking for. We know this angle is going to be 108, which means half of it is going to be 54 degrees, which means we're not going to be able to do our 30, 60, 90 triangles. We're going to have to use SOHCAHTOA, which means we're looking for this side and this side. Which side should we look for first? Doesn't matter. Let's look for x. So it's going to be the opposite side and the hypotenuse. So that's sine. Sine of 54 degrees equals the opposite over the hypotenuse. We solve. 19 times sine of 54 equals x. X is approximately 15.37. So there we go. X equals 15.37. So there's our apothem. So let's put that down here. Apothem 15.37. So now we need y. So y is going to be the adjacent in hypotenuse. So that's cosine. Adjacent over hypotenuse. So 19 times cosine of 54 equals y. Y is approximately 11.17. Okay, so our side length is approximately 11.17. So the side length will be approximately 22.34. All right, so this side is going to be 22.34. Since y is 11.17, and these are the same, so this must also be 11.17. Cool, so now we can find our perimeter. Perimeter is going to equal 22.34 times how many sides? 5. So that's going to be approximately 111.7. Cool, so our area is going to be 1/2 times the apothem. We got 15.37 times the perimeter. So we're going to get an approximate answer of 858.41 meters squared. Done. So good luck doing your homework. If you need any help, just ask during class, and I'd be happy to help you through email too. So don't be afraid to ask.